Morning, everyone. So I am Dr. Nohayati. We'll be having another webinar series for today. And today we are going to continue with another series or another webinar series where we're going to discuss or more or less what we are going to have another sharing session from different perspective of my field itself. Okay, so before I start, so let me introduce myself. So I'm actually a PhD holder from University of Malaya, whereby my field is on the plasma. All right. So I believe when I talk first time you listen to the word plasma, definitely most of you will think of blood plasma. Am I right? Okay. So today we're going to share like in a way once you heard this term plasma, so hopefully you will heard or you will think of something else apart from the blood plasma itself, or the plasma that where we normally use to encounter in blood. All right. So basically here I will going to share some slides so that we have some ideas, so we have some sharing sessions, some latest technology that have been encountered or that have been ongoing, whereby this hopefully with today's session I really hope that you get some benefits of it, you get some tips, or you get some info or ideas. Okay, when we talk about plasma, so you have the idea of definitely it's not something to do with blood only, but also you think of something else. All right. So now let's start with seeing some slides that I have prepared for you guys today. Okay. So now when we talk about plasma, again, as I mentioned, when we talk to a layman person, I mean to a normal person, to normal people, so definitely they will think of plasma which in blood. For those who are studying biology, definitely they will think of this, right? And not to mention other people as well, even though we are not from biology part or science part or science student, whatnot, definitely the first thing that they will think of is when I talk about plasma, definitely they will think of the plasma or the serum, the plasma which is inside the blood or inside our body. But somehow, apart from that, we have also plasma. It's also called plasma, but then it's considered as a reactive plasma. Okay, so now today we're going to see the differences between these two. And if for those who are still new to this, despite of whether it's blood plasma, whether it's reactive plasma, okay, so hopefully you have the idea of more or less like contrasting these two. Okay, so again, as I mentioned, my field is on reactive plasma, but I am here today just to give some overview of the comparison between these two. All right. So now when we talk about plasma, this is more on the biological part. Bear with me. I'm also not from this biological field, but somehow my field is more on the biological what do you call that? More on combining these two fields instead of where you have the systems together with the sample, which is the sample is from the biomedical samples. Okay, so not to go deeper. So basically, we have when we talk about plasma, what should we know about this blood plasma? Okay, it's also known as a blood plasma. Okay, plasma also known as a blood plasma, whereby it appears like yellowish or straw colored. It serves as a liquid base for whole blood, whereby it contains 91% to 92% of water and 8% to 9% of solid. This is according to Matthew et al. 2020. Okay, so definitely, I believe you have seen blood before, right? When you talk about blood, of course, you will see the red color one. But then that one inside the blood is actually consists of plasma. Okay, so whereby in this, when you actually, what do you call that? When you actually segregate the components of the blood, definitely you will see you have two portions. The first, the where it appears like yellowish or straw colored, that one is the plasma. And as you what do you call that? As you segregate these two, so you will have the red blood cells and you have the blood the plasma. Where this plasma it contains of this blood plasma it contains of water, ions, proteins, nutrients, waste, and also gases. Okay, but as you need to know that apart from this, it also has coagulants, whereby it mainly fibrinogen, whereby it helps in blood clotting. Okay, and plasma proteins such as albumin and globulin, whereby it helps in maintaining the colloidal osmotic pressure. Okay, and also it has electrolytes like sodium, potassium, bicarbonates, chloride, and calcium, which helps maintaining blood pH. Okay, and last but not least, it has the immunoglobulins, which helps fight infection and various other small amounts of enzymes, hormones, and as well as vitamins. Okay, so this is more on the, and you talk about blood, definitely you have to think of, there are two parts whereby you can actually put, or you can actually divide into two parts, whether it's the plasma or whether it's the red blood cells. Okay, right. Now, so what is the function? I'll just going to brief a bit on this blood plasma thing, just to give the overview or the differences between these two. Okay, so towards the end, we have come to the conclusion that what are the comparison, what are the differences, the main differences between these two. Okay, so plasma is commonly given to trauma, burn and shock patients, as well as people with severe liver disease or multiple clotting factor deficiencies. It helps in boosting the patient's blood volume, which can prevent shock and which can prevent shock and helps with blood clotting. Okay, definitely I believe those biology students, they have more information on this, but here I am only giving the overview of the functions of the blood plasma. Okay, so one of the plasma main function is the removal of waste from cellular functions that help to produce energy. It also accepts and transport these waste to other areas of the body, such as the kidneys or liver for excretion. Okay, and it also helps in maintaining body temperature by absorbing and releasing heat as needed. Okay, so in addition to transportation waste and regular body temperature, so plasma has several other key functions that are carried out by its different components. So basically, more or less, we know that plasma is the component of the blood, from the blood, whereby it consists of few components. Okay, whereby the function, some of the function is either to help in clotting, blood clotting. Okay, and it also helps to regulate the temperature. Okay, so now we have the blood plasma. Right, so hopefully you have the idea of what is the blood plasma. Now come to my part. Okay, so when you talk about reactive plasma, so I 100% believe that maybe that those who are layman person who are not actually heard of this before, so we have another plasma, right? We have another plasma in our life apart from the one that we have in our body, which is what we call reactive plasma. Right, so this reactive plasma, what is it? Okay, so those we deal with matter. Okay, we deal with matter. We have solid, we have liquid, we have gas. But somehow we have one more part, which is the fourth state of matter, which is what we call plasma. Okay, so it's very it's not it's not what do you call that? So commonly observed. I mean, you can see solid, you can see liquid, you can see gas. I mean, we will deal with this, right? I mean, we deal with gas, right? But somehow it's very rare to deal with this plasma. Okay, so now what is this reactive plasma and why is it called reactive? Okay, so this plasma, as we know that the third state of matter is the gas, but somehow after that, do we still have another matter? Yes, we do have, which is the plasma. But then how do we actually get the plasma? Okay, so as you know, from the solid, it will become gas as you give energy. As you heat the solid, of course, as you increase the temperature, so basically it will change in its form. Apart from the solid, it becomes liquid. And again, once you continue giving heat, definitely it will change its property. Apart from the solid, it becomes liquid, then it becomes gas. But what happens as you keep supplying energy to this gas? Okay, so what happens is it becomes ionized, right? So it becomes ionized. Okay, so as it reach certain temperature, so it will ionize and it will become reactive plasma. So that's why here we have, it says that gas plasmas are ionized gases formed by liberating electrons from gas molecules and atoms using external energy sources such as lasers or high electrical voltages. Again, it depends. If let's say, if you want to see, or if you want to generate the plasma artificially, definitely, as I mentioned just now, from the solid, you have to provide heat. you have to give heat. You have to increase the temperature of that particular object to change its form. Same goes with this plasma. So from the gas, as you provide or as you keep increasing the what do you call that, the heat or the temperature, or by increasing the temperature of that particular gas, so definitely it will have the tendency to become ionized. Okay, so during ionization, so of course here it will involve what do you call that, uh, the liberating electrons, okay, using external sources such as you can also use lasers or high electrical voltages. So later we'll see in terms of what do you call that, in terms of the way we generate the reactive plasma. Okay, so once ignited and under the influence of an external energy source, electrons and other charged particles, for example ion, are accelerated to acquire considerable kinetic energy, and as a result it becomes capable of ionizing, exciting and dissociating gas molecules, which means that it's not only involve ionization, it does involve excitation, it does involve dissociation. Okay, it depends on the conditions and the conditions that you have to meet. Okay, so from here, as you generate gas, as you provide or as you give external sources, or as you what do you call that, provide the gas with external source, so it will have the tendency to either ionize, either to become excited, or to dissociate. Okay, and to becomes ions, to becomes photons, to becomes then it will actually consist of highly reactive chemical species. Okay, so when these excited gas atoms and molecules relax back into their normal energy state, which is referred to as the ground state, so they will release photons. So basically, it actually consists of multiple or various processes inside the plasma itself. I mean, inside the gas itself. Once you have the gas, then you project or you give some external source, so it will become ionized. Of course, the electrons will actually get some energy. It will get excited. Okay, once it gets excited, it will revert back to the normal energy state. And during the reversion from the high energy state to the ground state level, of course, it will release some photons. Okay, so these species, so this plasma, once you want to create it, you will see that it will consist of multiple reactive species or various reactive species. Okay, so most of these are in the where you have the photons, and most of these are in the visible range, but some are in the ultraviolet UV and even vacuum or UV or VUV regions. Okay, so basically, you can actually see this plasma, right? So here I do not actually provide, but somehow you will see that it's more on bluish color, okay, or purplish color, right? So it depends on the type of photons, type of what do you call that, the UV, the ultraviolet that have been projected. I mean that have been released during the process. Okay, so from here you can see that most of these are in the visible range, but some are in the ultraviolet and even vacuum, and gas plasmas that may be thought of as a collection of coexisting chemically reactive species, energetic electrons and other charged particles, as well as electromagnetic waves, including UV photons in a stationary or flowing gaseous medium. So somehow you have from the gas, then you project the gas. You give the external supply or energy, so it gets excited. When it gets excited, it becomes ionized, it becomes dissociate, it will emit photons. Okay, so from here you will see that a form of bluish color will be formed. That one is when you already generate plasma, and whereby this plasma, it consists of these reactive species. So that is why it is called reactive plasma, right? So hopefully you get the idea of and hopefully you have the idea of the differences between the blood plasma and the reactive plasma. Okay, now here, as I mentioned, so you have it consists of neutral atoms and molecules. It depends on reactive oxygen species, what we call ROS. Also, we have where you have the reactive nitrogen species. Okay, again, it depends on the type of gas that you are using. Okay, so whether you are using oxygen gas, whether you are using nitrogen, whether you are using argon. So again, the type of species that you want to create, that you want to ensure that you have those kind of species in your plasma. Again, it depends on the type of gases that you are using. Okay, so from here you have the reactive oxygen species, excited atoms and molecules, as well as photons, electrons, and also free radicals. So basically, this ionized gas is this plasma also called ionized gas, whereby it consists of all these species. Okay, all right. Now this reactive plasma. Okay, now how do we create? As I mentioned that you have to supply or you have to give some energy. Like the blood plasma is already in our body. Okay, it's just that in terms of the extraction, so how do you divide the component of the blood into the plasma and also the red blood cells? But this one is more on artificially or laboratory basis. Okay, which means that you have to create or you have to generate this uh, plasma. I mean, in order to get the plasma, again, it depends on the type of plasma that you are looking for. Okay, so generally we can say that reactive plasma, it can be divided into two parts. Parts in a way in terms of high temperature plasma and low temperature plasma. Okay, so high temperature plasma, mostly the temperature is very high. Okay, it is mostly used in industrial applications. Okay, here we can say that it is equilibrium system, whereby equilibrium system meaning that all the components or the reactive species that I mentioned just now, they're having the same temperature. The photons, the molecules, all the reactive species, they are at the same temperature. So we are calling that system, or we consider that system as in equilibrium system. Okay, but for low temperature, it's non-equilibrium system. Non-equilibrium system meaning having the electrons are not having the same temperature with other species. Okay, so high temperature is more homogeneous plasma. Homogeneous means you have what do you call that, the you will see that the in terms more on the characteristics of the plasma will be different. But then here I do not actually plan to go deeper into this explanation on this too. Maybe in some other webinars. All right. So now we have this reactive plasma, whereby we can say that it's a high temperature plasma, it's a low temperature plasma. So again, it depends on the applications, right? So if let's say you plan to improve, or if you plan, or if you plan to generate plasma, let's say for example for industrial applications, why it is suitable for industrial applications, like you have the uh, plasma gun. Okay, so you have this another applications whereby it involves high temperature. Okay, but for the low temperature, mostly it is used for biomedical purposes, right? So for biomedical purposes, for example, you have in terms of the treatment of antibacterial treatment, in terms of blood clotting, in terms of cancerous treatment, okay, that kind of thing. Okay, so now hopefully you have the idea of these reactive plasma in terms of how do we generate this and the type of reactive plasma itself. Again, it depends on your preference, whether you are into the high temperature, whether you are a high temperature people or a low temperature people. All right. Okay. Now, again, as I'm saying that I am more to the low temperature, so basically I will just give to share some not too detailed, but somehow at least the brief idea of if you if your interest is more on like for me, I am more on biomedical part. I mean biomedical application. So definitely low temperature is the suitable plasma that needs to be slow temperature plasma, which is suitable to be used for these kind of applications. Right? Okay. So now again, how do we actually generate this low temperature? So here, as you can see, it requires high voltage. Okay, it requires, whether just now you'll see that you have laser or you have high voltage. Okay, meaning you have to use high voltage up to a certain kilovolt of voltage. Okay, whereby it's very high in order to ensure that the ionizations can occur. Okay, so from here, as you can see, this is the basic diagram of how are you going to produce or how are you going to generate plasma. You will see the plasma inside this. Okay, so this is actually the plasma. Okay, the bluish or the purplish color. Right? So you can actually observe the plasma because of the UV photons, or the what do you call that, the photons which actually dissipated or actually emitted during the process of, or during the generations of the plasma. Okay, so again, it depends whether it's in what do you call that, whether it's in whether it's observatory, or whether you are able to observe the plasma or not. But somehow once you create the plasma, definitely you can observe this bluish color. Okay, if it is not generated, definitely you will not see anything. Okay, so go back to this basic system of how are you going to produce, or how are we going to get this plasma. Is definitely what you need to have is just a simple setup. Okay, just a simple setup whereby you need to have two parallel plate, then you have to have two parallel sandwich together, whereby it consists of another layer of dielectric barrier. Okay, so this is called dielectric barrier discharge. Okay, whereby you have this one, the top part is the top electrode is connected to the positive, to the anode, and the ground electrode is connected to the negative. So as you supply, or as you give energy, or as you supply voltage here, so definitely they will discharge between these two plates. Okay, and from here, once the condition is met, you will notice that you will observe this. You are able to generate the plasma. Okay, so generally we'll see that this low temperature plasma is generated due to this DBD. Okay, and the plasma is confined to the gap between electrodes, and the use of the conventional DBD setup in biomedical applications has remained limited. Okay, so from here we have another type of the plasma. Okay, so this is more on the biomedical purposes. Okay, because different setup, we will create different according to the purposes that you are planned to have. Okay, like for my case, I am more to the biomedical field. So of course, the setup plays an important role for you to have or for you to decide what type of systems that you are going to produce. Okay, like for this case, we have this plasma jet. Why it is called plasma jet? Because of the configuration of the system. Okay, again, still the basic idea is still there, whereby you still need to have the power supply. You need still to have the positive electrode, the negative electrode, and then from here, as you can see, as you can see from here, the plasma is confined to the gap between electrodes, and the use of the conventional DBD setup in biomedical applications has remained limited. So this situation changed when investigators reported that with proper design, the plasma can be blown out of the discharge gap and into the ambient air. So definitely for application purposes, this design is suitable to be used for the treatment of antibacterial, or the treatment for cancerous cells, or any biomedical purposes. Okay, just to suit the device. Okay. Now, this reactive plasma, you can see the applications either in you will see that whether it's in wound healing, okay, in biomedical, industrial, and also agriculture. Okay, so from here, as you can see, this is actually the plasma. Okay, so more on the treatment on the bacterial part. Okay, again, it depends whether you want to have a direct treatment, or more or less we call water plasma activated water. Okay, whereby the water is actually treated by the plasma, and they use the water to further apply for another applications. Okay, so from here, as you can see from here, this is another example whereby they have the treatment of they use the plasma in the biomedical treatment. I mean, in a way, in terms of the inactivation of bacteria. Okay, whereby we use plasma to inactivate or to kill the bacteria. Okay, more on the surface treatment, or more on the sterilizations, whereby maybe it requires high cost or high maintenance. Okay, so basically, this is another options whereby reactive plasma, again, depends on the system that you are using, is suitable. I mean, again, it depends on the type of applications that you want to use. Okay, so apart from here, you can see that we also use in agriculture, whereby we try to stimulant, or we try to enhance, what do you call that, like from the latest research that they have done, I mean, in my lab itself, we plan to what do you call that, to increase, or we try to treat the papaya seed. Okay, we try to treat to treat a papaya seed so that we can help the time required. I mean the duration of time needed for the papaya to grow. Okay, so definitely for this, it's either when we consider that we use this plasma either as a direct treatment or non-direct treatment. Direct treatment means you give directly the plasma, like as what we have here, okay, directly to the sample. But then if it's involves non-direct, indirect treatment, so we call it plasma deactivated. Okay, all right. So now here is as the antibacterial purposes. I mean, in a way, like how does it works? How does these things work? More on the mechanism part. Of course, the mechanism I mean, the mechanism of the killing process due to the plasma still what do you call that? Still in further research. But somehow here what we have, just to get to give the idea of how does these things work. I mean, how does the plasma able to give the antibacterial effect? Okay, more on the, you can see the deformation of the cytoplasm, shrinkage of cells, leakage of cytoplasm. Okay, then you see in terms of the cell wall, you can see the breaking of chemical bonds, able to erode due to the bombardment of radicals, and it can also increase in surface roughness. Okay, and it can also involve lesions and perforations in the membrane. Okay, and from here you can see all this actively or reactive species, each and every reactive species that we have here, they are actually contribute to the mechanism, I mean to the killing effect of the, when we talk about the antibacterial purposes. Okay, now in agriculture, as I mentioned just now, or whether it is a direct treatment or whether it's water activated treatment, you can see from here, as you have the plasma, so it will straight away radiate. I mean, we treat directly, and then from here you will see that the effect in terms of whether it's to sterilized. Again, it depends on the type of applications that you are referring to, whether you want to ensure that there's no pesticides, because we know that the effect of pesticide is quite severe. Okay, so definitely this is another options. Okay, so from here you can see that the effect or the applications of this plasma, the reactive plasma, is quite various. Okay, apart from the, you can see the antibacterial part and the agricultural part. Okay, and also it helps in the blood clotting. As you know that, of course, the blood the blood plasma also helps in blood clotting. So we have some similarity here, whereby you have the blood coagulation. I mean, we use the non-thermal plasma. Some of the researcher who actually use this plasma in order to help, or in order to enhance blood coagulations. Okay, because in order to help in wound healing. Okay, so from here you can see that the blood coagulation effect of non-thermal plasma by using a multi-gas plasma jet. All right, so it is efficient to use plasma jet, and again, it depends on the type of gases that you are using. From here, these researchers, they are using argon. They compare in terms of different gases used in terms of argon, oxygen, helium, nitrogen, mock air, and also carbon dioxide. And it shows that the different sample or different species, different samples that we have here, it depends on, because they actually add in another 4 different anticoagulants. Okay, so the tendency is to ensure that whether the plasma jet system, whether it is capable in helping the blood clotting or not. Okay, so it says here that whole blood with each anticoagulant demonstrated fast coagulation by this non-thermal plasma treatment. Okay, now I believe we have come to the end of this series for today. But before I end my session, let me reiterate again. Let me give you the overview of this, just to give you some, hopefully at the end of this session, after hearing through all those explanation just now, hopefully you have the idea or the comparison, even though not 100%, but at least you have something for today. Okay, so again, we can say that this low temperature plasma, it has shown outstanding application value in also in pharmaceutical, not only in pharmaceutical, also they have in the latest technology whereby they try to use this plasma system, reactive plasma, in order to overcome the COVID-19 pandemic. Okay, and also the emergence and spread of antibiotic resistance call for development of chemical treatment options for bacterial infections, which means that apart from using all those chemicals, all those what do you call that, supplement or medication, so we come up with another system which we plan as an option. Okay, as an option. And plasma medicine applies low temperature plasma physics to address biomedical problems such as also wound healing and thermal suppressions. And many investigators have reported that low temperature plasma can be tailored to induce apoptosis in cancer cells without causing damage to healthy cells. And last but not least, what I can say is the blood plasma and the reactive plasma are two totally different substances. Okay, so with that, thank you very much, and I hope to see you guys soon. And before I end, uh, I welcome any questions or any comments or any feedbacks. And before we end, I really hope that for those viewers for today, you can actually fill in the Google form and then enjoy. That's all for today. Thank you.